What if Earth stopped spinning for just 1 second? Not slowed down, not gradually braked, instantly, zero rotation. You wouldn't notice it immediately, but the atmosphere would. Right now, at the equator, Earth spins at about 1,670 kilometers per hour. That speed isn't something you feel, because everything around you is moving with it. The ground, the oceans, the air, all locked into the same rotational frame. So what happens if the solid Earth suddenly stops, but everything else doesn't? The air keeps moving at over 1,600 kilometers per hour. That's faster than the speed of sound. The moment Earth stops, the atmosphere becomes a global shockwave. Every building, every tree, every human instantly exposed to supersonic winds blasting from west to east. Not like a storm, not like a hurricane. This is a wall of air with the energy of a planetary scale explosion. Glass shatters instantly. Structures collapse under aerodynamic stress. Anything not anchored deep into bedrock gets ripped away. But that's just the air. The oceans are even worse. Water doesn't stop just because the planet does. Entire bodies of ocean continue moving eastward at over 1,600 kilometers per hour. Coastlines are hit with mega tsunamis thousands of meters high. Not waves, continents of water sliding across land. Every shoreline on Earth is erased in seconds. Now imagine this happening everywhere, simultaneously. Cities vanish. Forests flatten. Mountainsides shear under the force of moving air and water. And still, it's only been a fraction of a second, because inertia doesn't care how long the stop lasts. Even if Earth remains still for just 1 second, that's enough time for catastrophic energy transfer. Let's quantify that. The rotational kinetic energy of Earth is about 2.14 times 10 to the 29th power joules. That's equivalent to billions of nuclear weapons detonating at once. If that energy is suddenly removed from the planet's rotation, it doesn't just disappear, it gets redistributed into the atmosphere, into the oceans, into the crust itself. The ground doesn't stay stable either. Tectonic plates, previously balanced under rotational forces, experience a sudden shift. Stresses redistribute violently. Earthquakes trigger across fault lines worldwide. Volcanoes respond next. Pressure systems inside the mantle destabilize. Eruptions increase globally, not because magma suddenly appears, but because the mechanical equilibrium has been disrupted. And then gravity starts to matter in a new way. Earth's rotation creates a slight bulge at the equator, about 21 kilometers wider than pole to pole. This happens because centrifugal force pushes mass outward. But if rotation stops, that force disappears. The planet is no longer pulled outward at the equator. Water begins to migrate. Oceans slowly flow away from the equator toward the poles. Not instantly, but the process starts immediately. Sea levels drop near the equator and rise dramatically in higher latitudes. Entire regions flood, not from waves this time, but from planetary-scale redistribution of mass. Now consider the atmosphere again. Without rotation, the Coriolis effect vanishes. This effect is what shapes global wind patterns, jet streams, and weather systems. Without it, atmospheric circulation collapses into a new configuration. Air begins to move directly from hot regions to cold regions in straight lines instead of spirals. Weather becomes extreme, unstable, and unpredictable. But remember, we're only dealing with 1 second. So what happens when Earth starts spinning again? Because unless something external stops it permanently, gravity from the sun and conservation of angular momentum mean the system won't stay frozen. Rotation resumes, but not smoothly. Everything that was violently displaced, the atmosphere, oceans, debris, now collides with a moving surface again. It's like slamming the brakes in reverse. Winds shift direction violently. Water masses crash back against coastlines. Again. Debris traveling at supersonic speeds meets a rotating ground. The second impact phase begins. Even regions that somehow survived the initial stop are now hit again, from a different direction. This isn't a single disaster. It's 2 overlapping global catastrophes, separated by 1 second. And we haven't even talked about orbit. Earth's orbit around the Sun wouldn't be directly affected by the stop in rotation. That motion is separate, about 30 kilometers per second. But the orientation of the planet changes. Day and night cycles destabilize. If the axis is even slightly altered during the event, long-term climate patterns shift. Ice caps could grow or melt depending on the new solar distribution. But that's a long-term effect. In the short term, survival is the real question. Could anything survive? Yes, but not much. Deep underground bunkers might endure the atmospheric shock. Submarines deep in the ocean could avoid the worst of the surface chaos if they survive the pressure shifts and underwater currents. Some microorganisms, extremophiles, and deep biosphere life would almost certainly persist. But surface-level ecosystems? They collapse almost entirely. And all of this from just 1 second. Because the danger isn't the duration. It's the sudden change in velocity. Physics doesn't care if it's 1 second or 1 hour. If you remove motion instantly, inertia turns that change into destruction. And here's the real takeaway. We live every moment moving at over 1,000 kilometers per hour on a planet spinning through space, orbiting a star, inside a galaxy that's also in motion, and we don't feel any of it, because everything shares the same motion, until it doesn't. And if that motion is ever interrupted, even for a second, the entire system collapses into chaos. Subscribe to Cosmic Earth if you want to explore more extreme physics, planetary scale events, and the real mechanisms shaping our universe.